Good morning. The purpose of the demonstration today is to show the capabilities using microwave technology to process the asphalt lake. This model was assembled to display proof of concept. The full-scale process and equipment is patent pending and has many proprietary aspects to improve efficiency and reclaim heat. Here's a shot of the control unit. The controller on the left shows a temperature reading of 34 degrees Fahrenheit, which is the ground temperature today, or 1 degree Celsius. The controller on the right is the blending fuel temperature. And this plot is an example of the material that we're processing. As you can see, the porous nature of it makes it difficult to conduct energy with traditional methods. And we've taken that same material and put it into our demonstration area. As you can see, the temperature is about 55 to 57 degrees Fahrenheit and is solid. We'll be setting the microwave transmitter on that oil. And this is a shot of the blending pot that the melted asphalt will be transported into. Now we'll set the cover on top of the microwave transmitters and get ready to begin our test. This is the pickup cup at the end of the oil slab. We'll be doing a continuous shot in this area so you can see through the process that the microwave has melted the oil. We run the microwave process for approximately 13 minutes and we're using 2 kilowatts of microwave power today to heat the oil. The full-scale unit will have 4 microwave transmitters which produce 400 kilowatts of power. Based on laboratory tests, we calculate that the efficiency will give us a production rate of over 1,000 barrels a day. This is a good example of what the oil looks like viscosity-wise once it begins to flow. This material looks to be maybe 150 to 160 degrees Fahrenheit. Once the oil reaches the pickup tube, it'll get sucked into the blending pot and be blended with the cutter diesel. This is an example of the material after the test. We show a surface temperature of 153 degrees Fahrenheit or 67 degrees Celsius. As you can see, all of the material underneath the microwave transmitter has been completely melted and is ready for processing. This is an example of the blended fuel coming out of the blending skid. Because the air temperature was very cold today, the ground temperature being 1 degree Celsius and the air temperature being about 40 degrees Fahrenheit or 4 degrees Celsius, we had trouble with the material re-solidifying before getting sucked into the machine. So we got some degree of blending today, but because of the cold weather, we had some material handling issues. To show a comparison with conventional heating, we put a similar weight of material in this pot and heated it up with a 7,000 BTU burner. 7,000 BTU burner is about 2 kilowatts, so this is a similar amount of heating as well. As you can see, some of the material is actually boiling whilst other parts of the material are still solid, and this is after 10 minutes of processing. That demonstrates the problem with conventional heating. The surface temperature has to be much hotter to drive the heat into the material, and for that reason a lot of emissions occur. You can see a lot of steam coming from the pot, and in our process we generated no steam or smell.